Welcome, dear student from S.Y.B.Sc, Nanoscience and Nanotechnology. Our first paper is Physical Techniques for Synthesis of a Nanomaterial. And in this paper, our first chapter is Physical Techniques. Friends, in this lecture, we have to see what is ball milling method. According to Richard Philman, there are plenty of a room at the bottom, or the number of volumes of an encyclopedia can be assembled or a single tip of a pin. So, what is this nanotechnology? Uh, which methods are used for synthesis of a nanomaterial? What is this synthesis method? So synthesis means method in which the nanoparticles derive from bulk material. The nanoparticles derive from bulk material or nanorods, nanotubes, nanowire, nanocubes can be also derived from bulk material. And this is the synthesis. Now, while considering the synthesis, we have to consider two approach. First is a top-down approach, and second is bottom-up approach. So, top-down approach in which breaking down of the bulk material. The ball milling method is in a top-down approach. Bottom-up approach in which build of a material from bottom, that is atom by atom, molecule by molecule, cluster by cluster. Cluster is the group of the particles. Here the soldier method is one of the bottom up approach method. Now uh, there are a different synthesis method. Basically we use four type of synthesis method. First is a physical method, second is a chemical, then biological, then hybrid. In a physical synthesis method, there are again two types. First is mechanical, second is vapor. In mechanical method, there is a high energy ball mixing method or ball milling method, then melt mixing method. Then in vapor deposition, there is a physical vapor deposition, laser ablation, sputter deposition, then electric arc technique. Okay. In while considering the chemical synthesis method, there is a colloids, sol-gel method, LB films, inverse miscellaneous. These are the chemical synthesis method. Then biological synthesis method, we can prepare the nanoparticle by using the biomembranes, DNA, enzyme, and microorganism. And there are also hybrid techniques in which there is a electrochemical deposition, chemical vapor deposition, particle arresting in a glass, then zeolites or polymer, micro emulations, zeolites. These are the hybrid method. There is also one of the hydrothermal synthesis method, which is also a hybrid method. Friends, we have to see high energy ball milling method. This high energy ball milling method is a physical synthesis and mechanical method. So, ball high energy ball milling method. This is mechanical method. Okay. It is one of the simplest way of making nanoparticles of some metals and alloys in the form of a powder. Simply, we can mill the bulk material to form nanoparticles of metals and alloy. Then there are many types of a mill such as planetary mills, vibratory mills, then rod, tumbler. These are the mill. A planetary mill in which there is a cylinder inside the cylinder. When the cylinder is a rotate, the balls inside that the cylinder is also rotate so that the we get a nanoparticles. Then vibratory method in which the cylinder is a vibrate. The in a rod, the rod is a rotate so that the particles come in contact with this rod, uh, uh, get synthesized, or the size of that particles reduce. Then the usually one or more container are used at a time to make large quantity of fine particles. Okay, when we have to synthesis only one material, then one container is used. Okay, if we have to synthesis more than one material, then one or more container can be used. Then the size of the container of course depend of the quantity of interest. When we have to synthesis large quantity of a material, then the size of a container is a big. Then hardened steel or tungsten carbides balls are used, are put in a container along with powder or a flask of a material of interest. Okay, we can use the steel or tungsten carbide ball. So the tungsten carbide ball are put in a cylinder along with the powder, and when the cylinder is rotate, the tungsten carbide balls are also rotate so that when the balls are come in contact with the material, then we get the nanoparticles. Of course, the synthesis or the size of nanoparticle is a depend on rotation of the cylinder, okay, or container. Then the size of a tungsten carbide ball. Okay, also there are some factors affect on the size of a nanoparticles. Now here is one of the mill. Here the cylinder is rotated so that the tungsten carbide balls are also rotated. Okay? The material is come in contact with the ball, okay, so that the size of this uh, bulk material is reduced. Okay, so simply this is the horizontal section. Then these are the uh, steel ball or the tungsten carbide ball. Then the centrifugal force is acting on this ball. Okay, so that they goes along the diameter of the cylinder. Okay, now this is planetary ball mill. Okay, here there is a cylinder inside the cylinder. Okay, when outer cylinder is rotated and inner cylinder is also rotated. Okay, and the ball inside the cylinders are also rotate. Okay, these balls are come in contact with the bulk material. Also there is a crushing of the bulk material along the wall of a container. Initial material can be arbitrary size and shape. So the material uh, have a different size and shape. Okay, container is a close with tight lids. Usually 2:1 mass ratio of a ball to material is advisable. Okay, 2:1 mass ratio of a ball material. Okay, if the container is more than half filled, the efficiency of milling is reduced. Okay, so the container should not fill completely. Okay, it should be fill it should be less than the half fill so that the efficiency can be increased. Heavy mill ball increase the impact energy of a collision. Okay, the larger ball used for milling produce smaller gain size but larger defect in a particle. The process, however, may add some impurity from the balls. Okay, the impurities are added due to the balls. Okay, then the container may be filled with air or inert gas. However, this can be additional source of impurity. When the container is filled with the inert gas, the impurity are added. Okay, if proper precaution to use high purity gas is not taken. Now, a temperature rise in a range of 100 degrees Celsius to 1100 degrees Celsius. When the cylinder is a rotate and the ball inside the cylinder is a rotate, then the temperature is a rise and it is in between 100 degrees Celsius to 1100 degrees Celsius is expected to take place during the collision. So the temperature is also affect. Low temperature favors the amorphous particle formation. When the temperature is low, the particle is amorphous. But when high temperature, then the crystalline particle can be formed. The gas like oxygen, nitrogen can be a source of impurities as a constantly new active surface are generated. Uh, then chylopooling is used sometime to dissipate heat generated during the milling. Liquid also can be used as a coolant. Liquid also can be used as a coolant, but it is a rarely used. Okay, cooling is a method is used which is used to dissipate the heat generated. Okay, when the heat is very high, okay, and if it is the greater than the it is it is about a melting point, then the very large impurity are added in the nanomaterials. The container are rotate at high speed. Okay, a few hundreds of rotation per minute around their own axis. Additionally, they may be rotate around some central axis and are therefore called as a planetary ball mill. Okay? Here, the container rotate at a high speed around their own axis and they may rotate around some central axis. So there is a cylinder inside the cylinder. When the container are rotating around the central axis as well as their own axis, the material is a force to wall and press against the wall. The ball that can be press the material along the wall, okay, because there is a container rotating around the central axis as well as their own axis. So there is a cylinder inside the cylinder. Now, by controlling the speed of rotation of a central axis and the container as as well as duration of milling, it is possible to ground the material to fine powder, few nanometer to few 10 of nanometer, whose size can be quite uniform. Okay, so what things affect, that is rotating speed, time, okay, rotating speed, time, then shape of a cylinder or the size of the cylinder, then the size of a ball. Okay, these factors affecting the formation of a nanoparticle. Now, advantages of a ball mills. It is a produce very fine powder. The particle size less than or equal to 10 microns, or we can say that it can be used to produce nanoparticles also. Then it is suitable for mixing toxic materials since it can be used in a completely enclosed form. So the toxic material can be synthesized by using this method, has wide application. Then it can be used for continuous operation. Okay, so there is a no reaction is carried out, only the cylinder is a rotate and the ball inside the cylinder is a rotate, so it can be used for continuous operation. This is also a low cost. Then disadvantages, the contamination of product may occurs as a result of wear and tears, which occur uh, principally from the balls and partially from the casing. Then high machine noise level, especially uh, if the hollow cylinder is made of material, but much less if a rubber is used. Then relatively long milling time, and it is difficult to clean the machine. These are the disadvantages of a ball milling method. This is the reference from which this study material is taken. Nanotechnology principles and practicals uh, by Sulbha K. Kulkarni. Then, okay, so this is all about the ball milling method. Okay, so in this lecture we discuss what is the synthesis, then the different types of a synthesis method, then ball milling method, okay, details of a ball milling method, advantages of ball milling method, and disadvantages of